Assalamu alaikum dosto, Bismillahirrahmanirrahim. You are studying Pelton Wheel Turbine and this is me, Engineer Irfanullah from International Islamic University, Islamabad. Let's start from the introduction. A Pelton wheel is an impulse type water turbine. First of all, it is the type of turbine which work under impulse of water. So, Pelton wheel is invented by Lester Allen Pelton in the year of 1870s. Pelton wheel is employed in the case where less quantity of water is available and high head is available. If the head is very high but the quantity of water is low, so we can employ the Pelton wheel turbine in such a case. Pelton wheel is a tangential flow impulse turbine, means the water comes and tangentially to the buckets of the Pelton wheel. Initially, the pressure energy of water is converted into kinetic energy to form high-speed water jet, and this jet strike the wheel tangentially to make it rotate. First of all, we have a reservoir of water and have some height of the water. So the water is arranged to move in a pipe called penstock with a very high speed to the lower altitude, where a turbine is set and the nozzle is set such that the high speed jet of water strike the bucket of the turbines and make it rotate. So it is also called as a Pelton wheel because it looks like a wheel, so that's why it's also called a Pelton wheel. However, it is a type of turbine. Turbine driven by jet of water issuing from nozzle, striking the bucket on wheel, cause it to rotate and develop power output. When the wheel is rotating, it produces and generate electrical energy. So first of all, the water energy, the pressure energy is converted into the mechanical energy of moving the turbines, and this mechanical energy is then converted into the electrical energy which are imparted to the grid station. So parts in their function of Pelton wheels. First of all, the most important part of the Pelton wheel is nozzle. You can see in this slide the nozzle. This is the nozzles which can be moved backward and forward in order to increase or decrease the area of opening. When we increase the opening, so the quantity of water will be increases while the velocity will reduce. If we decrease the area of opening of the nozzles, the quantity of water will be reduces while the speed and the velocity of the jet of water will be highly increased. So nozzle, the water from the source is transferred through the penstock, as I mentioned earlier, to the end where a nozzle is provided like this. So this water is coming from the reservoir to the penstock, as it have written here, penstock, and at the end of this penstock there is a nozzle, adjustable nozzle which can be adjusted to this spear. So using this nozzle, the high speed water jet can be formed. This is the jet of the water. To control the water jet from nozzle, a movable needle spear is arranged inside the nozzle. This is used to move backward and forward the nozzle in order to increase or decrease the area of opening of the jet. So the second most important part of the Pelton wheel is runner and buckets. A runner, this is runner. A runner which is a circular disc, and on the periphery of this runner, a number of buckets are mounted with equal spacing between them. So these are the buckets. So these buckets are headed by this water jet and make it possible that the Pelton wheel are revolving. So the third most important part in their function is casing. The whole arrangement of the runner means, suppose this is runner, this is mini Pelton turbines which are mostly used in the experiments performed in the lab. So the whole arrangement of runner in the buckets, inlet and braking jets are covered by the casing. So these are the casing. Casing of Pelton turbine does not perform any hydraulic function but prevents the splashing of water while working. So water coming from here, this is the inlet, there is a nozzle, water coming here. If there is no casing, the water will split here and there, so there will be the most disturbance. So the fourth one is braking jet. So apart from the penstock and jet inlet, there is another braking jet. The function of this jet, this is the braking jet. When the jet of water is completely closed, this one is completely closed by pushing the spear in forward direction, means the inlet of water are stopped and the amount of water striking the runner becomes zero, but still the runner are keep to move in the directions where it was revolving due to the inertia of the runner. How to stop it? Immediately, in order to stop the runner in the shortest possible time, a small nozzle is provided which directs the jet of water at the back of the vanes. This jet of water used to stop the runner of the turbine is called the braking jet. So this is the braking jet which are used to brake the turbines after stopping the operation. Water flow over buckets. How water is flowing is some of the parts are showing that this is the nozzle which are stationary. So the water coming out to the nozzle with a speed which strike the water bucket, the bucket of the Pelton wheel. So it move, and another bucket come in front of the nozzle, so which also gives some force to the turbine, which try to move forward and so on. So the working principle of the Pelton turbines now, the water is transferred from, so step by step we are going, the water are transferred from the higher source, high head source like dams and other reservoirs to a long conduit called penstock. At the end of the penstock there is a nozzle. Nozzle arrangement at the end of the penstock help the water to accelerate and it flows, means the nozzle also help the penstock to accelerate the water by reducing its opening area. So it flows out as a high speed jet with a high velocity and discharge at atmospheric pressure. So this high jet velocity water are used to rotate the turbine. The jet will hit the splitter of the bucket, which will distribute the jet into two halves of bucket, and the wheel start revolving. In the bucket, the design of bucket are such that it's are divided into two splitters. So two splitters, because in order to utilize the maximum power of the jet. The kinetic energy of the jet is reduced when it hits the bucket. All the energy are utilized in moving the turbine. And also due to the spherical shape of buckets, the jet of water will change the direction of the water jet back and falls into tail race. Tail race means there is a huge pipe going outward direction, so it collects all the incoming waters after hitting the bucket. In general, the inlet angle of the jet is in between 1 degree to 3 degree, while after hitting the buckets, the deflected jet angle is in between 165 and 170 degrees. Means totally opposite, means round about 180 degrees. So not 180 but near 170. So the water collected in tail race should not submerge the Pelton wheel in any case. Means the tail race water, means the outgoing water should not be huge enough such that the Pelton wheel is submerged in it. In this case, it will be harder to revolve the buckets in the normal speed. To generate more power, two Pelton wheels can be arranged. Means more Pelton wheel, more water will be required and more energy will be generated. Or two Pelton wheels can be arranged to a single shaft, or two water jets can be directed at a time to the single Pelton wheel. In this case, the Pelton wheel speed will be increased. The revolving speed of Pelton wheel will be increased, and two water jets are arranged such that the both hitting at the same time. It is further connected to gearbox and generator and battery for electricity storage purpose. As I have mentioned earlier, that the mechanical energy of this turbine are used to generate and store the electrical energy. So there is some cross section of the turbines. These are the runner. These are the turbines mounted on the periphery of the runner. So water jet coming like this, and these are the tail race. So on the left side, these are the spear which are used to control the nozzle. This is the nozzle, and this is the two splitter of a bucket. This is a single bucket having two splitters. The water jet come in such a way such that the maximum energy of the water jet are utilized. That's why the bucket is designed like this. So application and use of the Pelton wheel. First of all, Pelton wheels are the preferred turbine for hydropower, and when the available water source is relatively high hydraulic head at low flow rates. If we have a less quantity of water at a very high height, like in mountains, so this is a very preferred type of turbine to use to produce the hydropower. Second, Pelton wheels are made in all sizes for maximum power. Means it's not restricted to produce a single size of Pelton turbine. It can be resized and redesigned according to the need. So for maximum power and efficiency, the wheel and turbine system is designed such that the water jet velocity is twice the velocity of rotating bucket. I will explain it later, but you should know about that. The maximum efficiency of this turbine is at the speed of turbine. If the speed of the turbine system is half of the speed of the water jet, means if the speed of the water jet is 100, you design the turbine such that the water speed of turbine revolving is 50. So this will give you the maximum efficiency of the turbine. Third one is there exist in multi-ton Pelton wheels mounted on vertical oil-paid bearing and hydroelectric valves. Means very huge Pelton wheel can be seen in the hydroelectric power stations. Pelton turbine's suitability is discussed, like it is suitable for power extraction when water energy is available at high head and low flow rate. Efficiency and work done is work done by the jet on wheel per unit volume is equal to the force multiplied by the velocity of the runner. Mean this is the work done per unit volume, and this is the force, and this is the velocity of the runner. How you can find force? This can be found with the system and lab, like it's called torque. Maximum efficiency can be achieved by this is the runner velocity, turbine velocity, and should be equal to the half of the velocity of the water jet. So you will get maximum efficiency of the turbine. From the above equation, when the bucket speed is maintained at half the velocity of the jet, the efficiency of Pelton wheel will be maximum. Advantages of the Pelton turbine. So the advantage of Pelton turbine for a high head side is a good efficiency curve. Means efficiency will be maximum, is discussed earlier. Another advantage is the civil work reduced to a minimum. Means very minimum civil work in construction is required. Very minimum construction is required for mounting the Pelton wheel turbine in the electric power station. Problem due to the water hammer in the event of emergency shutdowns are overcome by the use of the jet deflectors. There is a problem of water hammer. Water hammer is a separate topic. We will discuss it in a separate video. Means it can be reduced. Water hammer is a huge problem in the dam system. So it can be reduced by the jet deflection also in case you are using Pelton turbine for generation of the energy. The jet size can be adjusted to change the volume, flow rate, and eventually to change power output so that it fulfills varying demands. Means you have the availability of a jet, you can change it, you can reduce its size, increase its size, make it forward, backward in order to have your maximum efficiency discharge to move the Pelton turbine. Thank you for watching.